Keynote interview on AI and cloud engineering, key aspects, for which I would like to humbly invite, with a huge round of applause, our moderator, Mr. Madhu Vadlamani, Practice Manager, Medical Software Systems. Please help me warmly invite our keynote speaker, Mr. Shashank Mohan Jain, Chief Development Architect, SAP Cloud Platform. Welcome, Mr. Shashank. With his wealth of experience, Mr. Madhu will guide us through a compelling conversation, and Mr. Mohan will provide us with invaluable insights into the critical aspects of these technologies. On that,
I am hungry as well, but we'll ensure that this session is a high-octane interactive session. No boring as such, trust me. So, thank you, Shashank. And before starting up, so one of the key discussions, let me summarize the overall findings from morning. The interest of AI is different, but the fear of AI is more. How many of you say yes? How many of you say yes that AI will kill the job, AI will rule off a job? No, you can raise your hands for sure. Some good hands. Some are hesitant at least. And many are hungry, I know that. So, first thing is that everything and anything in the world is not artificial intelligence. Yeah, Shashank, thank you. Starting at the right time.
Thank you, Madhu. And thanks everyone for inviting me for this talk. First of all, it's a beautiful city. I really liked it. So starting with the talk, the main focus, a lot of people have talked about large language models, AI and ML. I'll like to talk about a very specific aspect, that is the engineering aspect of how do we engineer these LLMs, right? So the main agenda is how do we operate, deploy large language models on the cloud or the AI models. It can also be like diffusion or image models, but primarily I'll focus on the LLMs here. And then there's an interesting aspect and the theory I primarily believe that majority of the AI models we see today will not be residing in the data centers of Azure or OpenAI, but they will be on your laptop, which is the kind of edge deployment you can say. Right, so discussing what is the main problems we have today on running the AI models on cloud. There are three main problems I can foresee. One is the problem of scale, like how do we build and deploy these big models. Take an example of a GPT-3 kind of model, which is 170 billion parameters model. Right, and 1 billion parameters or roughly translate to 4 GB of GPU memory if you are running it on the GPU, which means you are asking for 1 terabyte approximately memory on the GPU. Not everyone can afford it, right? And then how do you train such models if the need comes to? So this is the part of the scale where I'll discuss two main aspects. One is the training aspect and one is the inference part of it. And I'll keep it focused on scale, though there are other aspects like security where we have challenges around adversarial attacks on LLMs, etc. But I'm not going to talk about it. And similarly for operations, which is like how do you operate and manage and like monitor all these LLMs. Right. So for doing AI on the cloud, the two aspects I talked about, training and inference. So what aspects of engineering I look into when I have a need to train and infer an LLM. But you might ask the question, why do I even need to train? I just use OpenAI based models, use the APIs and do it. But then there are always concerns of privacy or data moving out to their data centers, right? So if you want to keep your data to you, address the security concerns, then primarily you will need some kind of open source models or homegrown models which you build or train on yourself and deploy it into your data centers. So the talk will be specifically like how do you do these aspects, what aspects you look into while you train such models. So for training at scale, we basically look into, like the Britishers did, divide and rule. So we do a divide and conquer strategy here. So there are three main strategies when we are training. We say we parallelize the data. What does it mean? Say for example, I have a machine which has 4 GPUs, right? So what I can do is I can say, if I have 10 batches, I can break it into, let's say, 3 batches each and place it individually onto each GPU. But what happens in this case, the whole model weights are still residing on each of the GPUs. So it might not be the best strategy to follow. But then there are other kind of parallelism which we exploit in the industry, where we say we have pipeline parallelism, where we break individual layers and place of the neural network and place into individual GPUs. But then there can be other optimization where we say instead of pipelining, why don't we look into individual layer or also break it apart, where we do the tensor parallelism. So instead of building all these things on our own, the industry or like Microsoft and other vendors have provided libraries. Like we can talk specifically about DeepSpeed as a library which can allow you to do this in a very, very easy way. So what you can do, basically you can take a big model and if you want to train it, you can use these kind of operators or these kind of primitives to do the specific trainings. Now, there are other optimizations also possible, right? So when we are training a big model, the constraint is always the GPU memory which we have, because GPU is a costly resource. So then there are evolved methodologies and frameworks like where we do gradient checkpointing, where we do gradient accumulation, and then we can also do optimizations like operator fusing, etc. on the graph of the neural network. I'm not going to do all the details because of the scarcity of time here, but you can look into these kind of aspects when you are really going into training your own models or fine-tuning your own models. The other aspect is, someone talked about earlier, like if there's a model, big model like GPT or Llama, which is like an Einstein for you. But for industry use cases, you might not be specifically looking at this model to answer all your questions. So you have your own data set where you want answers coming from that data set or your model to understand that kind of a data set. So there we apply the technique of fine tuning. So imagine, let's say we take a specific use case of an Llama, which is a meta-based model of 70 billion parameter model. You can do this 70 billion and fine tune, which means fine tuning is the adjustment of weights of these or the parameters of that model. So you can adjust all those 70 billion parameter model. But again, if you load all these 70 billion parameter model, then you require huge amount of GPU. So this might not be an efficient strategy again. So what we have in the industry, prevalent in open source, is a methodology called PEFT, which is parameter efficient fine tuning. The name itself says I am playing with the parameters and deriving efficiency from there. So there are two basic aspects of it. One is called LoRa, which is called the low rank adaptation, which is coming from the matrix. We decompose the matrix into low rank and then use it to fine tune. So imagine the weight matrix as a big matrix of 70 billion parameters. We squeeze it into a small matrix and then adjust the weights there. The techniques to squeeze, I mean, there are very specific methodologies, but you can think it of like this. So if you have a big matrix, all weights might not be important or relevant. So the method we use is to choose the very specific relevant weights which are needed for my data set and then adjust them. So this is the LoRa, which is a low rank adaptation, and then there is another technique called QLoRa, which is the quantized low rank adaptation. So quantized means reducing the precision, let's say from 32-bit going to 16, 8 or up to 4 bits. Now you can also see models which are 2-bit precision, right? So this is saying that I still use LoRa, which means I squeeze the matrix, but on top of that I also quantize it, right? Which means my computation and the memory requirement further reduces. So these are some of the techniques which, if someone is interested in fine tuning, can look into and apply. The other aspect I mentioned was the inference scaling, right? So let's say once you have fine tuned the model, now you have to deploy it and make it performant so that it responds very, very fast, right? What do we do about it? So one is that you, instead of using the full weights, use the quantized weights. As I said, like instead of 32-bit precision, we go to 16-bit, 8-bit or 4-bit depending on the quality you anticipate from the model. And for doing this, again, I mean, there are a lot of accepted tools like Hugging Face Transformers is there, C Transformers is there, Llama CPP is there. So all of these tools, there's a very evolved community now which can allow you to do all these things. The third aspect is very important, which is called speculative decoding. So what is happening in this case, if you generally understand the GPT architecture, the decoder one, where what is happening, based on the tokens it has seen, it is just acting as a next token predictor. So if I am speaking, the very utterance I say, I am, the model is already predicting speaking, right? And multiple of such, and based on the probability which is the highest, it takes that. So, but if you think it is a sequential prediction which is happening, which might be slow. So in case of speculative decoding, what they do is basically they do a teacher-student kind of a scenario where they take a small model and make it predict ahead of time, right? So in this case, what is happening? So you just run your sequence through the small model, get all the tokens, and then ask the large model only to check whether it is right or wrong. So this considerably increases the performance of your predictions which you are doing by the LLM. And finally, what you can do is like you can take the big model, you can again do the divide and conquer, you can break it apart into multiple parts, where we call it sharding, and say, okay, I will take the weights, put one layer onto one GPU, other layer onto other GPU, and then parallelize the calls. And same thing can be applied on sharding across multiple machines. Okay. Now this is the part on the edge side, what we can do when I'm specifically talking of models which might not be deployed onto the data center of Azure or data center of Google. What you can do is you can take these models, quantize them, squeeze their size into small, and run into your own laptop. So I was able to run a coding model onto my laptop just with CPU inference. There is nothing more. I don't have a GPU on my laptop, but everything works from there. Not the quality you are expecting for GPT-4, but specifically it does your tasks. Again, here you can make use of libraries like Transformers.js and Candle. I would have shown the demo, but because of the internet connectivity, I'll not be able to show, but I'll just show you the UI there. And what basically they are doing is, for running these models right into your browser, they use a mechanism called WebAssembly, where everything is packaged into a WebAssembly module and directly loaded onto your browser. So it uses the browser memory as the mechanism to execute and load these models. And if you can think of this, this is the extreme security what we can get, right? Because your data is not going out anywhere, you shut off the internet and everything works from there. So let me just show you the screen. I cannot show you the actual demo. Called Transformers.js, and all you see there are quantized model which they have loaded here, right? So if you see here, there's a series of models. One is translation, it is 78 MB. But if your task is only doing translation, why do you need GPT-4, right? You can just load these models right into your browser and the quality is decent, is all I can say, right? Similarly, you have model like speech to text. This is based on the OpenAI model called Whisper, which is open source. Again, a 41 MB model which just does the transcription of all your audios. So this is, I would have loved to show the demo, but because of the internet, I could not have shown. If you see the bottom side here, it is trying to load the weights, right? But unfortunately, it cannot be done. So
Yeah, it's done?
yes.
Yeah. Shall we start? Yeah. Thank you so much for your demo and quick things. Big round of applause for him. Sorry, I have to make you run, but still. So thank you, Shashank. Let's keep it simple and clear, and no tricky questions to anything. Okay. So on a layman terms, how do you say or how do you convey what is LLM?
Okay, thank you. So for a layman term, think of it like this. There's a village and there's a storyteller, right? So, and he's starting the story, and he starts the story by formulating sentences, right?
Yeah.
Yeah, so basically what is happening from the perspective of an LLM, it is that you start to speak, and based on what you have spoken in the past, it tries to predict what will come next, right? So when you are telling a story, you are coherently forming, right? What I have spoken and what I have to speak next. So many in the industry will still say whether an LLM is just a stochastic parrot, right? So it is just parroting and just fluently trying to deceive you, because if you see the fluency of the model, it looks like whatever it is saying is right, but that might not be the case, right? But in the end, I mean, it is just a next token predictor. In simple terms, if someone wants to understand, next word predictor.
It's a next level predictor. You
Yes, just next word predictor.
Next word predictor. Okay. Let's talk about the security and privacy issues.
Mhm.
In a process of using a lot of AI platforms or GenAI platforms, intentionally or unintentionally, even me at some point, where we had tested, for example, deepfake, or how secure is the data in AI and cloud, and what are the parameters even a normal man should consider when he uploads his personal or any kind of data, even for a POC?
So, I mean, this question comes to us from time to time, even when we are solving industry use cases, right? I'll answer it this way. So today itself, if you think, all our deployments are on the cloud. Not of machine learning I'm talking. In general, our database, our records, everything. So we trust the cloud provider to provide us with the right primitives of securing, like encrypting the data at rest, encrypting the data on the travel or on the air, on the wire, right? So once these primitives are in place, I think things should be fine. But there's a caveat here. So it's not necessary, as I also told in my talk, I am a big believer that the final model what will come will be on the edge, right? Where you will say that my data should not go out anywhere. Everything should work on my device, on my mobile, or on my browser itself. Which means that you can have very, very fine-tuned models, personalized models, specific to your need, your requirement, running right onto your devices.
Okay, thanks for that. And any, okay. In a process of judging a platform, especially in AI or cloud, let's say the client doesn't have any kind of an option and he has given to us to choose the better one.
Mm-hmm.
What are some of your initiatives or some of the pre-steps which you consider for you and your team to go ahead with this cloud platform? Or what are some steps?
Is it around the AI models?
Cloud-based, choosing a cloud platform.
So cloud-based is majorly around the SLAs the cloud provider is providing. Let's say you talk of any specific cloud service like an object store or something, we generally look into the SLAs they give, right? But since this talk about machine learning, if I want to choose a specific model, I will look into the evaluation matrices, right?
Okay.
On the different evaluation matrices, how this model is performing. And whether I need, again I will say whether I need that from the specific cloud provider or not, or I can live with an open source deployed onto my private data center as well. So, I mean, these are the specific things which we look here,
Okay.
right?
Now, in terms of doing your small projects, generally AI and cloud always works when you have huge data. But what if there are some entrepreneurs who like to work even with the small models? What are some very quick advices which you like to give them so that they can test and deploy their model with a low cost? Because everything is costly these days.
Yes. Yeah. So I think this is partly covered in my talk when I was talking about the fine-tuning part, where I said not everything should go to ChatGPT or GPT-4, because if I am simply developing, let's say, a question answering system on top of my documentation, which is around, let's say, 4 or 5 PDFs, I probably won't need GPT-4 because it is the best model we have today, in my opinion. But for having a question answering system, it might not be the only model we will need. So what we intend to do is take any of the open source model and then fine tune it onto our data set. If we don't want to do a fine tuning, we can have what we call the retrieval augmented generation or the RAG mechanism. Just upload your document and develop a chatbot on top of that model, which is like, you can think of 2 billion versus like a trillion parameter model. This is the thing you can specifically do. And there are people who are running like a Mistral model I can talk, which can just run on your mobile today.
Cool. Great.
Mr. Madhu, my sincere apologies for interrupting. If you could just try and wrap up now, start to wrap up.
Yes.
Thank you so much.
Any questions from audience? Yes. Questions to me or you, Shashank? Or both of them?
Chatting on AI, but I just want to give one idea came into my mind. I also asked this question to sir also as well. So we in the Bitcoin, we have a whole blockchain Bitcoin mining. Okay, so where anyone can contribute to the blockchain network and they can basically run their GPUs, and from that they get the incentive from that. And the work of the GPUs is validating the transactions. So what Sam Altman has told, in India we don't have the infrastructures and funding to run make our own model. So what came into my mind is that we can make a decentralized computing power specifically for the AIs. Okay, and anyone can run their node, and if they run their node, if they process something or if they did some tasks with the help of GPUs and CPUs, they will get some kind of incentive via tokens and any other things. So I just want to is it possible to build?
Yes, definitely possible. You can look into.
Yeah. So all those things are happening.
So look into a framework called Petals.
Petals.
Right. It is exactly doing what you are talking about. So you can put your node and load what I talked about, like the adapters, or like when you are doing your own weights there onto your node. And there are different layers people are running into the network. And there are the name I forgot, there is one more model which also does monetization on top on this, like the token system basically.
So like in India we can run this and we can make our own. Yeah.
In India, we can do lot many things. That's the reason we have been there here. So, one last question from, say, in a process of doing this, right? Data modelers, data engineers plays a major role, right? So, how impact is that in terms of judging your data when you upload in any kind of systems, say AI and cloud?
So come back again.
So, data modelers and data engineers are playing a major role over here, right?
Right.
Data, in terms of whenever you're trying to do any kind of a deployment in AI or cloud, right? How impact are these people?
Okay, you mean the people who are working on data modeling
data
side?
modeling and engineering side.
Yeah, so definitely, I mean, in my opinion, there are two aspects again. One is people who know the machine learning and AI side of things, and the other set of people who know the engineering of it.
Yes.
Right?
Yes.
So both are important and both are very, very different roles. Right? So I talked about the aspects of fine tuning. So fine tuning will involve some of the aspects of AI and ML, but majority of the aspects is around engineering. Right? Because I don't want my training to run infinitely. I want it to be performant. So what kind of engineering I should apply to make it a performant training or fine tuning? So I mean there are very, very defined roles which will become more and more important, I feel.
Yes. Having said that, one quick check here. Data is the new oil for sure. Data is the new oil. Only when you use the data perfectly, or else the data is the oil for namesake. So just we need to refine the data and use the oil perfectly. It all depends on how it is.
Yes.
And I think I might have extended 30 seconds, but still.
That's just all right. And we are really sorry because we just want to be on time, and that's the whole reason for the request. In our gratitude, I would like to invite Mr. Shastri from Zen to do the honors, please. Mr. Shastri, please welcome Mr. Shastri with a huge round of applause. Welcome, sir. Mr. Shashank, thank you for your insights and please accept this appreciation. Thank you so much. Gentlemen, you can pose for a group photograph if you wish to.